Have you ever wondered how the stars we see twinkling in the night sky came into existence? What is the cosmic recipe that cooks up these massive glowing celestial bodies? Today, we will delve into the fascinating process of star formation. Consider a vast cold cloud of gas and dust floating in the interstellar medium, the space between the stars. This cloud, known as a nebula, is where the magic begins. The nebula contains the ingredients needed to create a star, primarily hydrogen, along with helium and trace amounts of heavier elements. Gravity, the universal force of attraction, pulls the particles in the nebula together. As the particles get closer, the gravitational pull increases, leading to a snowball effect. As a region within the nebula starts to collapse under its own gravity, forming a dense core. This is the birthplace of a star. This core, now called a protostar, continues to collapse, causing the pressure and temperature at its center to rise. When the core temperature reaches a staggering 10 million degrees, nuclear fusion begins. This is the process where hydrogen atoms combine to form helium, releasing a tremendous amount of energy in the form of light and heat. The protostar has now ignited and become a main sequence star, shining brightly in the cosmos. The star remains in this state, burning hydrogen into helium for millions to billions of years, depending on its size. Larger stars burn hotter and faster, exhausting their fuel supply in a relatively short time, while smaller stars can remain in the main sequence for billions of years, glowing steadily. Once a star exhausts its hydrogen fuel, it starts to burn helium and other heavier elements. This causes the star to expand and cool, turning it into a red giant or a supergiant. Eventually, the star exhausts all its fuel and collapses under its own gravity, leading to a spectacular supernova explosion or a quiet fade into a white dwarf, neutron star, or black hole, depending on its mass. To summarize, the birth of a star is a cosmic dance of gravity and nuclear fusion. It begins in a cold, dusty nebula where gravity pulls particles together to form a dense core. This core collapses under its own weight, increasing in pressure and temperature until nuclear fusion begins. The star then glows brightly for millions to billions of years, burning hydrogen into helium. Once the fuel is exhausted, the star expands and cools, eventually collapsing and ending its life in a dramatic explosion or a quiet fade. The next time you look up at the night sky, remember the incredible journey each twinkling star has undertaken. From a cold, dark nebula to a bright, glowing beacon in the cosmos, each star has a story to tell, a cosmic tale of birth, life, and death.